You could load the model by, if you knew how many kilograms you wanted to put in from the Susquehanna River and knew the flow on that day, you could give it this concentration. We just don't do it that way. Okay, so that's why you will see, it's you don't realize, but you see like temperature has a Susquehanna River boundary condition because as a rule we don't load massive temperature. Salinity is zero, you know what I mean? It's kind of not obvious, but dissolved oxygen, it's 8. So for things like salinity temperature, we give it a concentration. If it's loaded, you make it 0.
At the ocean boundary, and this is a question because I don't know the answer, is the dissolved oxygen actually 11 or does it go up much higher in the winter and get lower in the summer?
This is patterned after reality. So day 0, we start in January. And it suggests that the oxygen in at the mouth
day 0 loading, so it changes. I'm sorry.
Would be about 11.
It's not a constant. We're looking at the boundary conditions file, and it has changes on your monthly time steps. Got it. Sorry.
Kyle.
There's a full version of the model where you have many more boundary conditions for different rivers. Is this also limited by width, or is this limited by width of 80 characters here too?
This is formatted. Yeah, so I don't know how many we got across. 1, 2, 3, 4, 5, 6, 7, 8. You'd wrap. You'd wrap. And these initial, when you wrap, you can leave these blank. You can put anything you like in them. The format statement will skip them. So it will wrap. So that's, now. Okay, so I think we covered that. Now here comes the devil. All right, we're going to go back, and this is one of the most painful, excruciating things about ICM. Okay, so we've told the model how many boundary conditions? 4. We haven't told it where. Remember that in the load file, after we told it how many, we gave it the box. What we don't tell it here, and I don't know why, and I'll say I didn't write this code. I'm just going to say we didn't tell it. So how does it know where the boundary conditions are? It goes to the map file, and remember the pairs of zeros? So it goes to the map file. We'll bring that one back. Have I still got it open? Yeah, here's a map. And the way it does is, and this is the most painful, excruciating thing about ICM, it reads boundary conditions in the order in which these 0 pairs are encountered in the map file. So let's see. So here's a 0 pair, and it's at face 1. So what it's going to do is it's going to take the first boundary condition, and it's going to assign it to that first pair of zeros. So it's going to take 5 degrees and assign it to face 1 because that's the first pair of zeros it encounters. And then it's going to say, where's the next pair of zeros? Here it is.
No, in a line 11.
There it is, face 11. There's a pair of zeros. So what it's going to do is it's going to take, so it says this is face 11. So it's going to take the next temperature that it encounters in the map file. Well, that is the map. It's going to take the next temperature that it encounters in the boundary condition, and it's going to assign it to face 11. It's going to assign it to face 21. It's going to assign it to face 31. That's easy enough in a 30-box model. When you get to actually assigning boundary conditions for Chesapeake Bay, Lord help you. Because the map file is created by this little piece of software that you append to CH3D. And the order in which it encounters things in the map file is not anything rational. Okay. Let me try to explain. I'll go back to this one for a minute. Okay. You and I, rationally, what we're going to say is, this is the Potomac River. I want to assign boundary conditions to the Potomac River. This is the Susquehanna River. I want to assign boundary conditions to the Susquehanna River. But what CH3D does is it goes around the bay, and it does surface layer, and it does the surface layer. Then it goes to layer 2 and goes around the bay. Then it goes around the bay. So sequentially in the map file, rather than all the Potomac River ones being sequential where you could enter them easily, it's going to take the surface layer in the Susquehanna, the surface layer in the Rappahannock. It's going to take the surface layer in the Susquehanna, the surface layer in the ocean, the surface layer in the Rappahannock, or whatever that one is, James, the surface layer in the Potomac. Now it's going back, and it's going to take layer 2 of the Susquehanna. Oh, well, that's not so bad, but the Susquehanna here is how many layers deep? It's 8 layers deep. The ocean is 19 layers deep, and the James is 2 layers deep. So after you go around this for 2 layers, now it's going to go Susquehanna, ocean, skip Potomac. And then later it's going to say, oh, the ocean's all that's left. So this is extremely painful. And what you have to do, and we'll go over this Wednesday morning.
Doesn't explain why you didn't retire 10 years ago.
Well, it's the devil. And what you have to do is really you require, I call it a translation program. You go into the map file, you pick out the order in which these boundary conditions occur in the map file. And then you have your own set of boundary conditions inputs where the model reads rationally, here's the Susquehanna River, here's the ocean, here's the Potomac, here's the James, and it writes them out in the order in which they're encountered in the map file. So you need that processor, and even making up that processor is, well, you need that. And it can be, I don't know how much level of pain I want to explain, but the map file only gives you, okay, I'll stop there, I won't go further. But what I say is what you need to do is to go into the map file using a text editor, or you can write some software. Find the order in which boundary conditions are encountered, and then you're going to have a program which actually has the boundary conditions in a rational sense, and you have a Fortran program that reads these rational boundaries and spits them out in this format. And we'll go over that program, we'll go over an example of that on Wednesday morning.
Is there such a program?
Yeah, it's distributed in your package. Again, actually, it's good in a way, you hear this from the horse's mouth. I mean, it's documented, but these are some things that it's good to get them across. You hear, you hear it from the horse's mouth. So, okay, okay, so that's the boundary conditions. What else have we got? Okay, this is more or less what we just went over. As with the loads, the boundary conditions remain constant until they're updated. So we tend to specify them monthly. So whatever boundary condition you specify on day 0, it's going to stay there until day 30.4, and it's going to stay there until day 60 and so on. You can specify them at any interval you like. You can update them at any time you like. There you have it. Convention, we specify loads of carbon, nitrogen, phosphorus, and solids. Boundary conditions are specified as 0 so that the loads are not input twice. It's not a rule. If you want to give pollutant concentration in inflows, you can. We specify all substances that open boundaries, such as the estuary and the ocean. You need to give all of them. Otherwise, they'll be 0. Please.
The ugly leap year question.
Excuse me?
The ugly leap year question. You just add leap days from the beginning of the run or the actual calendar number of days, including leap days?
Well, each actually will, boy, oh boy, okay. If you have 10 individual load files, let's say, they always start at 0. Okay,
Gotcha.
so if you had a 366-day leap year,
It would go to 366.
there you go.
Okay. And if you had them on one, it'd just keep running and include the leap days.
Yeah.
Oh, so I had asked the question earlier, whether the load files were done sequentially so that at the end of the first year, let's assume it was an odd year, you'd be 365. I would have assumed the next input would have been at 366, 367, but you're saying that the second file starts back at 0 again?
The model, the thing that keeps track of model time
Right.
does not go back to 0, but the load files are,
Index the first day.
they always start at 0.
Oh, so somehow, again, the program internally knows it's in the second file and had to add 365 or 366
Yeah.
to it. Oh, I didn't realize that, okay.
Yeah. Otherwise, we just have, well, anyway,
Okay, no, I would have thought
yeah.
you would have just really continued time as time. Okay. Because if you wanted to have a separate program that actually read the file and plotted them, then you'd be fouled up as you'd be coming back to 0 all the time.
yeah.
Okay, all right, now I understand that, okay.
Let's see, so we've gone through the PowerPoint. Have we looked at everything? We've looked at the loads, we've looked at the boundary conditions, we've looked at the control file, no? There it is. So, where's my control file? So, okay. As you know, there's a lot more in this file than I want to go into, and I advise you, the manual that I distributed is reasonably accurate in describing all these things. As Dan mentioned to us, I'll just do this a little bit. Down at the bottom, you have to give it the number, the names, and the locations of all the files. And you'll notice in keeping with our tradition, this is all formatted and it's all required. Now, you tell it the number of time-varying files. Some of these files do not vary with time. So for example, the map file, you read the map once and it's in there. You read the geometry once. You read the initial conditions once. You read the algal growth rate parameters once. On the other hand, when you get down to, whoops, where'd they go? You get down to hydrodynamics, now you need, you read multiple hydrodynamics, basically traditionally annual files. So, and you'll notice in keeping with what I mentioned to you before about that NX, you always need one ahead. We're going to make some, later on, we're going to make some 10-year runs with the 30 box model this afternoon or tomorrow. The input files are 1 year long, but I specify 11 of them. So when it gets to the very end of that last time step and it wants to read ahead one, there's another file that it can pick up and it'll run successfully to completion. Let's see, anything else? So, you'll see that, for example, you have 11 S2 loads. Now, I'll mention, in the 30 box model, we have S1 and S2 loads. We don't have the S3 file is off, it's not opened, but you're required to put that space in the control file.
Can those files be null?
Yeah, I mean, this isn't even located anywhere. It's never going to try to open it.
It won't, oh, but you still have this, okay.
But it is going to read
A name.
this many names, and it's going to expect that after it reads S2, it's going to look for 11 S3
So it doesn't
names.
actually, it'll read it, but doesn't actually try and open them
No.
right away. So you could put in the word null if you wanted.
Anything you like.
Unit. Okay.
Anything you like. Let's see.
And wait, did you just say that the number of files has to be consistent for S1, S2, and S3?
That variable we called NHYDF, number of time-varying hydrodynamic files, was 11. That carries over. If you say 11, any file that is time variable, you need 11 of them.